Alrighty, everybody. I just got the okay to start our planetarium show, so I'm going to be putting away our space trivia questions because now we're going to be heading into the unknown. Ooh. And good afternoon, everybody. Welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, what's up, y'all? Hey, how's it going? Don't hurt your necks, though. Look forward into the dome before you. That's where the whole show is going to be. Everything that you see in purple is going to be one enormous screen, thanks to the help of 6 different projectors hiding throughout our planetarium dome. And I am very pleased to have y'all here because this is by far my favorite show. This is different from all the other shows that we've done here at the Morrison Planetarium. This one is called Tour of the Universe. And this show is completely live, so you're going to hear my voice for the next 30 minutes as I fly you through space. And what this show pretty much we're going to be doing, we're going to be starting off pretty close to Earth, and we're going to zoom all the way out to the very edge of the observable universe. Hopefully, by the end of the show, you won't have an existential crisis of where we are in space, but I do need to warn you because we're pretty small in the grand scheme of things, so just a forewarning. And before we get started, folks, I do have to go over some quick house rules just so that we're all on the same page. There's a lot of us in here right now. So first off, there's no food or drinks allowed in. If you have any snacks, make sure those are put away till the end. If you happen to have any cell phones, smartwatches, tablets, now is the perfect time to turn them off. Put them away for the next 30 minutes as this room's going to get really dark. Having a really bright white light is very distracting for you and the people sitting behind you. Also, folks, if you need to leave early during our show, you're more than welcome. All you got to do is exit through the top. That's where you're going to find the exits before, during, and after the show. If you have trouble climbing the stairs, don't worry. Once the show is over, we'll have a staff member escort you to a lower exit. Just stay seated once the show is ended. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel motion sensitive, there's a really quick trick for you. All you got to do is close your eyes, take a few big, deep breaths, and your brain is going to remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. Hee hee hee. But with that being said, looks like we're ready to go. So let's begin our tour of the universe. Alrighty, everybody. As I mentioned, we're going to be starting off pretty close to Earth. We can see the Earth just down below, all the city lights popping up in the dark. But again, we're going to be starting off a little bit higher at this really cool spacecraft called the International Space Station, or the ISS for short. Now, a lot of people tend to ask me, hey, Christian, what's the International Space Station? I hear about it all the time in news and articles, but I don't really know what it is. Could you explain it for me? Well, of course, folks. The International Space Station is a research facility, a laboratory that orbits around our planet Earth. And how this came to be? Well, a bunch of countries across the Earth came together to create the space station where they can test out different science experiments. And they do all sorts of science experiments up here on the International Space Station. Some of them are things like, how do plants grow in space? Do the plants grow the same? Do they grow differently? What happens when you try to spark a flame in space? Does the flame act the same? Does that act differently? So all sorts of science experiments are conducted here at the International Space Station. But what's really neat is that this thing is looks really big on our dome right now, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, don't worry. You can also use the entire California Academy of Sciences, the museum that we're sitting in right now. That's about how big it is. And also, what's really neat is that this thing is going incredibly fast. The International Space Station is traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, this looks really far above our planet Earth, but the International Space Station isn't too far away either. It's only about 225 miles above the surface of our planet. 225 miles, that's like going from San Francisco to Santa Barbara. A nice little road trip to get away with the family for the weekend, so not too bad. And also, folks, this is as far as we put humans into space nowadays, only 225 miles above the Earth, because traveling to space is very, very expensive. You got to buy yourself a rocket ship or make yourself a rocket ship, and then you get to get your hands on a whole lot of rocket fuel. And I mean a lot of rocket fuel. And once you get your hands on all that rocket fuel, you have to account for all the food, water, all the air you're going to be breathing while you're up here in space. So the bill gets really expensive really fast. But the International Space Station is just the first stop on our tour of the universe. So now we're going to see it start to slowly disappear. And before we lose track of the International Space Station, I want to add a nice little orbital path so we can keep track of it as we zoom away from it. And it looks like right now we're just hovering just above the Caspian Sea. Alrighty, folks. So now we zoom so far back now that we're looking down on planet Earth. And I do want to let you know that the space program that I'm using here in the planetarium for this show is something that you can go home and download if you want to try out yourself. The space program that I'm using is called OpenSpace. So if you go to your favorite search engine, type in OpenSpace Project, you'll come across the link where you can download it, and it's a whole lot of fun. But just a heads up, this program is in its beta phase. It's not completely finished, so we may come across a few bugs and glitches. If we do, I'll point them out. Hopefully we can look past that. And also, just to warn you, OpenSpace uses a whole lot of processing power. So if you have an older computer, I wouldn't recommend it. If you got something newer, like a gaming computer, give it a try. It's a whole lot of fun. But if you're a person like me that doesn't want to download anything, not too good with computers, well, we also have another great alternative called NASA's Eyes. So just like the human eyeball, type in NASA's Eyes to your favorite search engine, and then you can fly through space without having to download anything. So we have OpenSpace and NASA's Eyes, and it's a whole lot of fun, folks. But now that we got a good sense of what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. Now, we humans have been to the moon before, but that was quite a while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science here, and of course, they had some fun. They got to play some golf as well. And luckily for us, we're inside of our planetarium, so I have some special abilities. So let me turn off the nighttime on the moon. Hey, that looks much more familiar. Good to see you, moon. But again, folks, last time we humans have been to the moon was 1972, a little while ago, a little more than 50 years ago or so. But don't worry, humans are planning to make a return trip back to the moon in the next few years, thanks to NASA's new space mission called Artemis. Pretty much, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we want to figure out exactly how we're going to live in space. So the moon is the perfect stepping stone to figuring out all the logistics, how we're going to live out here in space. And what's also really cool about Artemis is that they're going to be sending the first woman to the moon. But not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also going to be setting up lunar bases throughout the moon. Pretty much our technology has improved in the last 50 years, and our science equipment is much more compactable, so we can do a lot more science with a lot smaller equipment. And we definitely want to go take a look at some certain features on the moon that we weren't able to test out 50 years ago. One of the main places we want to check out is the south pole of the moon, where we've come across a lot of ice, and ice could be very useful for setting up lunar bases. And maybe we want to go take a look at some other features around the moon, like some collapsed lava tubes towards the north, or maybe we want to go take a look at some really high mountains that we weren't able to take a look at in the past. But what's also really cool about Artemis is that they're going to be having a space station orbiting around the moon at all times, kind of like the International Space Station that we just saw. So if anything was to go wrong while these astronauts were on the surface, those astronauts could head to that space station where they would be safe. So again, we humans are planning to head to the moon in the next few years. Look out for any news about Artemis. And folks, when we look up at the moon here from Earth, sometimes the moon feels incredibly close to us. It feels like you can reach out your arms and touch it. But the moon is incredibly far away from us. It's about 240,000 miles away from the Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind. So everybody say bye-bye, moon. See you later. So cute. And now, folks, we're going to be stepping into a much larger realm of our solar system because now we're going to see the moon and the earth as they start to slowly disappear. In fact, as we lose sight of them, I want to add some nice little trails so we can keep track of them. You can easily lose stuff out here in space. So there goes the earth and the moon. And folks, on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to computer models like OpenSpace showing us the most accurate images available to us. And now the nearest star to us, the sun, comes into view. So here comes that sun. Do. And folks, the sun is also incredibly far away from us. It's about 93 million miles away from the Earth. And again, we're the third rock from the sun. So 1, 2, 3, that's us, 93 million miles between us. And in order for sunlight to travel that distance, it only takes sunlight about 8.5 minutes at the speed of light to cross that 93 million miles. Now, this is a really cool concept to keep in mind because let's say the sun was to turn off all of a sudden, it's no longer producing light. That last bit of sunlight would travel that 93 million miles, that 8.5 minutes, and then all of a sudden, the daytime here on Earth would become nighttime. And that's just such a cool concept because that works for really far away objects as well. Let's say we're looking at a star that's 70 light years away from us. Well, we're looking at that star as it looked like 70 years ago because that light traveled 70 years to get to us. So when we look at really far away objects in space, it's kind of like looking back in time in a sense. Pretty cool. But now we have a nice bird's eye perspective of our solar system. So let's get a quick refresh of what's inside of our solar system, shall we? Right in the middle, we have our star, the sun. The closest planet to the sun, we've got Mercury. Then we have Venus, Earth, and Mars. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have this really cool thing called the main asteroid belt. And this is what it would look like if I highlight all the asteroids in our asteroid belt. There is a lot of them. So there's our asteroid belt, lots and lots of asteroids. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We've got Jupiter, the biggest one. Then we have Saturn. And then we have our icy gas giants. We got Uranus, the funny one, and Neptune. And of course, we can always add everyone's favorite and lovable dwarf planet, Pluto. So here's the orbit of Pluto. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, the Kuiper Belt's going to be all this stuff, folks. So we're looking at the Kuiper Belt, and pretty much the Kuiper Belt's like a second asteroid belt. Mostly what you're going to find out here are icy asteroids and short period comets. Comets that don't stray too far away from the sun. They have a nice little short period like that. And pretty much in 2006, we found more than 400 objects out here in the Kuiper Belt region. And that's pretty cool because as our technology improves, we're able to see much more harder, difficult to find objects. So we found all this stuff in our backyard, in our own solar system. And who knows what we're going to find in the years to come as our technology gets better. But I'm going to put away the Kuiper Belt because that's just a whole lot to look at. And right now I'm going to be adding on screen some of the many different spacecrafts we sent out in the 1970s to explore our solar system. So on screen, we're now going to have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2. There they are. So here's all the spacecraft trajectories. And all of these spacecrafts are traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventures, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. Only 5 hours. That's not too far either. But folks, let's leave our planetary scale behind because now we're going to be heading out into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us over 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. All right, now you're able to see all the star systems closest to us, and Alpha Centauri is going to be the one on the very bottom left right over here. That's the closest star system to us. And again, 4 years at the speed of light just to reach the next star system. Well, that doesn't really put it into perspective of how long it would take us humans to travel that far. Well, if you're to get in a rocket ship today, left planet Earth, made your way over to Alpha Centauri, it's going to take you about 8,500 years to cross this distance. And that's just a one-way trip. Whew. But folks, let's stop and consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. So again, we're now inside the radiosphere, and the radiosphere represents the current limits of the most distant radio signals humanity has ever broadcasted or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And also, folks, since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's magnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year. So is anybody out there listening? And right now, folks, I'm going to be adding on screen some many markers. These markers are going to indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found 5,000 exoplanets confirmed in our nearby vicinity to us, 5,000 other worlds besides our own. Whew. And that 5,000 number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. Now, to say if any of them are Earth-like with conditions suitable for life as we know, well, we can't answer that question quite yet. Pretty much new spacecrafts are being developed right now to answer that question. So it's going to be a few years before those are launched into space and conducting science. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in this star system on the far left of the radiosphere. We find an alien civilization somewhere in the middle. We shoot them a text message. We say, hey, we live here. It takes 60 years to get to them. They listen in, answer back another 60 years. That is a 120-year conversation in the making. Whew. And I could barely wait for a text message from my friend. But of course, folks, planetary systems beyond our radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And right now I'm going to be putting away the exoplanet markers. And I'm going to leave our radiosphere up on screen because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way Galaxy. Alrighty, folks, we're now looking down at our Milky Way Galaxy. This is the galaxy we live in, and can anybody see their house from here? Just kidding, that's way too far away. And folks, our Milky Way Galaxy is enormous. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years to cross it just one way. Ooh, 130,000 light years across. And not only that, our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within our small neighborhood, within this vast star city, is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. But before we leave the Milky Way, I do want to show you what it looks like from a sideways perspective. When you look up into the night sky here on Earth, you probably heard someone say, hey, look, you could see the Milky Way from here. And you were like, what's that? What they're referring to is this. We live in a flat spiral disk of our Milky Way. And when you look up in the night sky, you're seeing this right here. That's the Milky Way that you see. And this is important because when astronomers want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south instead of looking through the plane of our Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So keep that in mind. We like to point our telescopes galactically north and galactically south. But folks, the Milky Way Galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. Now, just to let you know, folks, we live in a local galaxy group which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And also, folks, as we start to zoom out, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or no galaxies at all. So we can see a nice galaxy cluster right over here. We can see some galaxy clustering over here. We can see very few galaxies towards the top and no galaxies at all. Now, you can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, we've zoomed so far back now that the picture that we're looking at represents the closest 30,000 galaxies to us across a space over 300 million light years across. We've got to give thanks to an amazing astronomy team that worked at the University of Hawaii who compiled this amazing representation over decades of time. But now we have automated systems that are mapping even the most distant galaxies. Folks, we're about to see the very large-scale structure of the universe. And remember, folks, every single point of light that you're seeing, that's not a star, that's an individual galaxy. Woo. And also, just a heads up, our universe is not shaped like a bow tie or a butterfly. Remember when I mentioned that we live in a flat spiral disk of the Milky Way? Well, if you line it up just like so, our Milky Way would line up right down the middle like so. So again, we like to point our telescopes galactically north and galactically south. And you can see that scientists still wanted to look for galaxies through the plane of our Milky Way. We have this nice purple survey there, but you'll notice that they didn't find as many galaxies, not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to map out all those missing data points. So you can kind of think of all those galaxies, but in every direction. But folks, it looks like we're running drastically low on time on our tour of the universe. 30 minutes is just not enough time. So let's continue pressing on, because now we're going to be encountering these really distant objects known as the quasars. And the quasars are going to be represented by these nice orange dots at the very edge of the large-scale structure. We got some quasars there, some quasars over here. And quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away, so now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe, and before there was a teenager, there was a baby. So let's press back to a time before quasars, galaxies, stars, before all those formed. Folks, we're about to see the very edge of the observable universe. Alrighty, folks, here we are at the very edge of the observable universe, and what we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. Now, all evidence indicates that that the universe that we live in is about 13.8 billion years old. And this is data compiled by Planck and other radio telescopes. And the picture that we're looking at is the very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this is not a typical photo either. Instead, this is a temperature density image where the light echoes of the Big Bang are color-coded with the lighter areas corresponding to the hottest, least dense regions and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these tiny differences eventually gave rise to that large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us, so we only have one direction left to go, and that's going to be back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies, and let's return back home, folks. Alrighty, folks, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes and preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we just made our way back into our Milky Way Galaxy. We're heading straight for that radiosphere. And of course, folks, we are making our way downtown, walking fast, spaces pass, and we're home down. Do 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 do. And now we're approaching our star system, folks, our solar system. And now we're about to pass the Kuiper Belt and those spacecrafts we sent out in the 1970s. And we're making our way to the third rock from the sun, our homeworld, planet Earth, the only place we humans have ever called home. And it looks like we're about to pass the orbit of the moon, the furthest we've ever sent humans out into space. And as we make our final approach back to planet Earth, folks, this is going to be the end of our tour of the universe. And I want to thank you all for stopping by and watching it with me today. I hope you did enjoy it. But hey, look at that. We made it back home safe and sound. And that's all for today, folks. Thanks for stopping by.